Hello, everyone. Welcome back to another episode of Dev. Joining me today, I've got Matt Coles and a special guest, Aaron Senf. So Aaron is also from AWS as well, and a very nice attire you've got on today, Aaron. You're looking right the part there.
Thanks, Paul.
And Matt, I think I see something a little familiar that you're wearing today.
Yeah, a little bit the same actually. The virtual reinvent hoodies. Somehow we managed to secure these very valuable pieces of merchandise. There was only a thousand of them that went out, wasn't there? If I remember, they were quite. Yeah,
there wasn't as many as there sometimes can be those specific years. So yeah, we were the lucky few. But for our audience, welcome back to Devs in the Shed. This is a segment that Matt and I have been running and are continuing to run weekly. And we like to explore AWS features, do some live hands-on coding, but also sometimes get off the keyboards and try and get onto the tools. Last week was our first episode where we did a bit of hands-on and we built some flashing lights on a breadboard with a Raspberry Pi. And a couple of people actually messaged me afterwards asking about where that code was or what were the certain components that you might have used with that. So I did package that up into a little repo, which I'll paste in the chat. So I'll paste it in there for everybody to have a look from. And yeah, I think I myself am a solution architect at AWS. Matt is the principal technical account manager at AWS. And Aaron, how about you give us a bit of an intro of who you are?
Sure. So I'm also a solutions architect at AWS. I'm in the partner team. So I manage one of the AWS's GSI partners. And I guess that's probably my day-to-day. And on the side, I like to get involved in our internal Unicorn Gym and projects that we do on the side, like the stuff that you, Paul, and Matt are doing right here.
Yeah, sounds really great. And I know that you've been looking at one of our new features or newer released features, and you've found that to be pretty exciting. And you've thought that maybe you would give us a bit of an overview of how this works, how to stitch it all together, and use some of these services within a React app, a React Native app. Sorry.
Yeah, sure. So location service, as you know, has just gone general availability. And for me, location service is quite an important service in a lot of the applications development that I've been doing over the last few years. So I in taking a look at what's available, obviously there's a range of SDKs for specific like iOS or Android. So if you're doing your native coding, and there's a lot of services that you can tie together sort of on the back end for your applications, for your web apps, what I wanted to take a look at today is actually one of the more important features of location services that I think probably doesn't get enough airplay or enough attention. But before I get into that, I mean, let's take a look at essentially what is location services, and then we can take a look at what I want to put together. So as I said, location services has just gone general availability. And in a nutshell, what location services does is it provides a few features around map tiling. So as most people are aware, there are providers out there where you can plug your maps into your apps or your web pages to provide map tiles. So we now provide a map tiling system based on Esri and here at the moment, and then we also have more providers coming in the future. Which allows you to select from the underlying maps and templates to provide a map in your app. From there, we also have place indexes, so you can actually do place lookups. So generally called a POI, or a point of interest. We can look up street names or general points of interest in the Esri or here database of points of interest to look up reverse geocoded or the actual coordinates of a common name place. Beyond that, or the
so
next,
that would be like that would be just to articulate that would be like McDonald's over in let's say St Kilda, right? Like that would come up as a common location, correct? Yeah.
Absolutely. So I'll give you a really good example of when this is used, and it's when it's used in an actual really important situation. Is when you call emergency and you're actually, you're looking for a police or ambulance or something, and the call taker on the phone is saying, where are you? And you're like, oh, I don't know. Like, I'm not looking at my phone. I don't have my GPS, but I can see a street sign. So you might go, oh, I'm on the corner of such and such, right across the road from McDonald's. And so that call taker can actually start to do a lookup and go, oh, okay, that's that street, and there's a McDonald's there. Okay, I know exactly where you are. And on their system, they can now see the geographic location of where you are based on those points of interest. So that's actually a very important underlying piece or feature for understanding reverse geocoding, or understanding where you are on the map based on points that we've got listed in the database. Beg your pardon. The next and the one that I want to go further into today is trackers. So trackers is essentially the ability to send your device location into the location services, and it can either be done on a per application basis, or it can be done bulk. So you can actually send a whole lot of device locations up. So because we can do a bulk upload of locations, there's a range of scenarios that you can use to actually, if you're doing fleet management and you want to send a whole lot of devices all at once, or if you're just tracking an individual device and sending that up. So there are a couple of different ways of doing tracking of devices, and sort of the more common ways, or the more common way, I should say, is more around the IoT space, where you've actually got an IoT device and you're using MQTT protocol to send the location of that device into AWS through IoT Core, and then actually talking to the location services from there. So I want to go into a bit of a similar scenario, but I'm tackling it from the point of view of developers and app developers, specifically for mobile, where you may not be accustomed or used to using like MQTT protocol or working with embedded systems, but you're aware of the application development frameworks like React Native, and even if you're doing native development in iOS or Android. But I want to tackle it from the point of view of let's think we don't know anything about native development, and we can do it from a React Native, cross-platform point of view. So we can write a simple bit of code, and I'm going to use a couple of other tools from AWS that make this really easy. But before I get into that, the last one, again, another important feature is the Geofence collections. So a Geofence collection is essentially, it's a boundary of geographical points which create a fence, a virtual fence. And you can have a collection of fences so that you can actually track a device moving through regions or zones. Again, this is important for, things like knowing where the closest, if you're doing a navigation, you're trying to plot a route to somewhere and you want to know where the closest hospital is or the closest McDonald's is. And when you cross into a boundary, that boundary might say, well, I'm this, McDonald's in this boundary. But again, in a different scenario, going back to the emergency call taker, when they've got your location, then they now want to know, okay, well, who is the right, let's say, police officer to send out to that crime? And it actually may be based on the jurisdiction, so it might not just be the closest police officer. You might have to say, oh, well, we need to select a police officer from the right jurisdiction. So a geographic location can show, well, this person is in that position, but then the geofence collection shows, well, every vehicle or every police officer in that geofence are the people that we can send to that event. So that's essentially what the features of location services are. And now I will, before I jump into the actual code, I want to show you how easy it is. So I'll jump over to the console, the AWS console. And basically all of the features that I've just described are here in the console. What I want to do is, for the purposes of this demonstration, I'm just going to set up a new tracker. And this will actually show you how easy it is to get started. So I don't need to know anything about maps, map tiling, geofences, anything like that. All I need to do is create a let's call it new tracker. Add a description. At the moment, my data is going to be sample data. So we'll just say yes, which means all we're doing here, if I select no, it's going to take you through a couple of extra questions to understand what kind of billing or subscription service you're going to use for tracking. At this stage, it's just going to be request-based because it's going to be sample data that we'll be sending. And that's it. Create my tracker. So I now have a new tracker created on such and such date. Obviously, we've got our ARN for it. None of this is really important. All I really need to know is the tracker name for exactly what we're going to be doing. So
just to think about it, Aaron, I might rewind a step.
Yeah, go
so I mean, this looks fantastic for me, right? Because I used to create apps back in the day where there would be like legal fishing areas in Victoria, and so I'd kind of like create like this this polygonal reference, like this, you know, point-to-point reference, kind of like, yeah, exactly like in that picture. So it was like it was a geofence essentially. Yeah, that's a better term. I'm like pulling up old memories from 7 years ago. But like people that were in that box were fishing in legal areas, and so they knew that they were good. But we'd give people warning when they went out of those areas to say, hey, you know, this part of the creek's actually illegal. There's protected fish in this area. You can't fish here. So this would have been fantastic for me. But as a native developer, I always think back to, you know, I do know a little bit about maps. I do know about Google Maps, Apple Maps. And I guess the advantage to this is like connecting into all those other systems. So maps aren't just localized to a device. Like you've got a geolocation that you might bounce around multiple systems. You need to display a consistent map across multiple systems. You might need to show geofence grids and all that. Have I kind of understood this correctly?
Yeah, that's that's exactly right. And the beauty of this is it's not actually in the map tiles. It's a GeoJSON file. So you actually have a JSON file in a specific, it's called GeoJSON, so a specific format, which actually explains the polygon, which is the actual fence of the boundary of all those geographic locations. So you're exactly right. And if you already know a map system, you could use, you might be using a free map application to embed into, a free map provider to embed into your application. You can actually use the geofence locations from that GeoJSON in your app. But what the beauty of this is on this side, so on the AWS server side, is you can now start to set up events for when you're starting to link a tracker to a geofence location. You might say, right, I want devices to receive a notification once they cross over into a specific geofence. So for your fishing example, you might have a couple of different fishing areas, and there may be a couple of different fisheries authorities that manage those areas. And those fisheries authorities, they actually might want to send you a very specific message about the area that you're fishing in to make sure that you're complying to their regulations. You cross over into one of those boundaries and you might receive a mobile message just saying, oh, okay, well, there's new rules about this area. And all of that has been because you're tracking your location through your app, and then you're receiving the notification based on the fact that your device on the back end has shown that it's crossed into one of these geofenced areas. So 100% spot on.
That's I worked in real estate, and I remember like years ago we had the same type of setup with geofencing and different sort of blocks with different agencies or different offices within the same agency, and that's exactly what we're wanting to do. So if someone crosses into a certain area, well, the call or the inquiry is directed to another area, to another specific office. And secondly, the reverse marketing pitch for that, like you may be active and on the lookout specifically on that day, and you can get alerts that, hey, a new property has gone up specifically within the area that you are in today. And we know that based on your schedule that you've told us earlier, that you were looking in that area. So here's another one that might be like a benefit. And rather than, displaying a property for sale that's, 30 kilometers away or something like that.
Probably the two examples that I've seen of using geofences, probably the most or the most effective, is one in the retail industry. Retail really works well with geofences, especially with franchises. And you might have different sales or different things going on at your different franchise locations. And for the users of your app for that franchise, when you cross into a specific geo boundary, like a geofence, getting an offer, hey, you know, come in and spend something in our store today, you know, and get a free blah, you know, or, you know, buy one, get one free because you've gone into a different area. That's one example that I've seen actually used a lot across the different types of franchises as well. The other one is more specific to an event. Like we all love music festivals. We all love, you know, like wine and food and, you know, all these different types of festivals we have. And actually setting up geo boundaries within the festivals, the festival presenters actually had an app for the day. And they had all these, you know, they had the schedule of what's going on. But then if you wanted to know more, you can say, oh, yeah, these are the things that I'd like to know more on. But as you crossed into different geofence boundaries, it would send you more details and say, oh, hey, in the next 5 minutes, somebody's going to be presenting on this. Or if you cross into another boundary, they're like, hey, come and get a free taste of, you know, what we're cooking over here. And it's just amazing, like actually having the interactivity of knowing where to go, as opposed to the old days where you kind of got your schedule and your map and you go, oh, we've got to get to the other side of the showgrounds to see what it is, and we get there too late. So for me, those are probably some really great examples of where it's been used really effectively.
Yeah, you could also do like geocaching games as well. Like people are in an area, you're getting closer to whatever it is, right? And then you can kind of give them an alert when they're right on top of the point.
Yeah.
But yeah, the other thing around, I guess, that as well is I always think beacon devices could be the alternate. But this is probably a little bit more reliable as long as the device location's accurate, which I know iOS do ask that sometimes. Yeah,
absolutely agree. I differ in that the actual the event one, that would be great for your beacons. But the thing that geofencing does, it allows you to span out over a much larger distance. Because as you know, with a beacon, you're limited to the Bluetooth. You're limited to the actual frequency that you can pick up the beacon. As soon as you drop out of range, you've got no idea sort of what the actual location is. Whereas with a geofence, in this respect, you can span a much larger area, and you're only just sending, you know, it's back to the cloud. So you're sending your location back to the cloud, and it's doing all the processing of what area you're in, all based on just sending a simple latitude and longitudinal coordinate through the tracker. And that for me, that's exactly why tracker is one of the most important features, is because without actually sending your data back to the cloud, without actually knowing the latitude and longitude of all the devices out there, you can't, well, you can, but it becomes more difficult to connect the other services together for an end-to-end solution. Like using a ride-sharing app, you know, like it's easy to say, all right, I've got my GPS coordinates on my device. I can have the map on my device. I can see where I am on the map. And then when you say, hey, you know, I want to ride, and it, you know, sends it back to the server, and it comes back and it says, all right, well, there's 4 vehicles in your area. Well, it knows that because it's looking at the individual tracking of each of the individual devices and you, plus what's the distance from you to those drivers. And it could be geofenced based on different ride share providers or different contracts or whatever. On top of that, when the driver says, oh, yep, I'll select that ride, then you're actually looking at your location and the driver's location on the map. And that's still all through tracker. So the tracker is now not only sending device location, you're actually being provided a device ID so that you can track the location of that device. So now you're saying, all right, well, I'm here and I can see the vehicle, because now we're doing a query to say, get device current position, and then just track it. So every 3 seconds, update the device position, bang, perfect. So you're
that's pretty
building
cool. Yeah.
End-to-end solution starts with actually starting to track the devices.
And I think E7 Twitch mentioned on the channel, like, this is really good for tow truck drivers, right?
Perfect.
Has anyone used Amazon Location yet? I'd be interested in the chat whilst we're going around the table. Or do you see interesting do you see interesting use cases in the apps that you're building for your job or personal projects where this could be quite handy? Whilst you're mentioning that in the chat, I might get Aaron. Could you tell us a little bit about the price? I did see 1 or 2 people asking how much this cost.
Yeah, so it is. Let me actually just jump over to the actual product page, because I can never remember all these things on the top of my head.
Oh, trust me, I'm the worst as well. Yeah.
There obviously is the free tier. Like everyone, you know, when you sign up for when you first sign up your account, you've got the free 12-month tier. So that's included with the location service. But as I was saying before, like depending on how you select how you're going to be using the tracker in this instance, it can differ on the pricing plans, like whether it's request based or whether it's subscription based. So are you actually paying an upfront price for a whole lot, or are you just paying per usage? So let's go down to pricing plans. That's the free tier. Here we go. We were looking at tracking, and
I can see Sydney there as well.
Australia.
That was my next question.
Yep.
So it is in our region. Yep.
Yes, it is in our region.
What were the other regions, just out of interest? Let's just have a quick look there. So Singapore's there as well. That's awesome. Tokyo, cool. So we've got a couple of ones in APAC, which is really handy.
Yeah. It seems to be in every major continent, maybe not in every major city.
Yep.
But so here we go. So we're looking at, in terms of like sending positions to the backend, you're looking at 5 cents for every 1,000 requests. So it's not an overly expensive service. They never are. So, and this is where, so as I was saying before, with Tracker, you can actually batch update. So a batch update, so batch position read or a position write. So if you're actually sending a whole lot of devices and all of their locations all at once, that's still just one request, yeah? So if you've got 1,000 requests per 5 cents, and then you're sending, say, 100 devices all at once, then bang, there you go. That's one request, 100 devices. It's very small because it's the device ID, the tracker name, latitude and longitude. That's it. It's a very simple query. Okay,
and another question that someone's asked is, what about like open source or available Geofence collections? So if you want to build a personal project, for example, and you want to get a whole bunch of locations, I think Location actually does that for us, doesn't it?
Yeah.
Yeah.
So the actual this is what we were saying before. The place indexes are actually those points of interest exist in Esri and here. So you can actually use the existing points of interest. What was the other part of the question?
Open source or available Geofence collections. So it looks like we've got some here, and I'm guessing we also have a marketplace as well for some different points or something like that, kind of maybe in the plan.
Yeah. So and then we're obviously we're always adding additional features and extending the existing features. But as I said, because it's all GeoJSON, it's sort of industry standard. Yeah. So yes, you can use your GeoJSON boundaries that you've set up before in the same way.
Yeah. Cool. Okay. Oh, I think this is making a bit more sense for me, and I can see the questions have calmed down in the chat as well. So let's go back to the actual service page. I'm really keen to see what you've built for us today as well.
To the service page?
The AWS console page. Yeah, there we go.
Oh yeah, no worries. Cool. So all we've done at the moment, as I said, so before we just went in and set up a tracker. So essentially, the easiest part of setting up an end-to-end solution is getting your device location in, and that's it. So we set up a new tracker, and now all we need to know is that tracker name for now when we want to set up a device to start sending the GPS coordinates to that tracker. What we can do from there is let me bring up. I don't have it open. Let me show you a little bit of a diagram that I put together around sort of this from a simple end-to-end solution point of view. So what we were talking about is basically in the location service, we've set up a tracker. So we now have a place to send all our location coordinate information. What we want to do is we want to get the mobile client, so your mobile device, to send that location information into location service. But then, as I was saying, for the end-to-end solution, we also want to be able to pull that location service information out. Now, from the simplest point of view, let's just say we have an app where we want to see all of the mobile devices that are out there tracking to this tracker. All we need to do is in our static app. So I basically using S3, to create a static app in JavaScript. using the map tile service, so we can go and get the map tiles from location service. So we have a Mapbox SDK for integrating with your JavaScript app, and then using the map tiles from location service. So that sets up the map, and then all we want is the actual location position, so the device position, from the location service to display on that map. So then all we're doing is we're making another query to get location service tracker device location. So we're making a API query to the tracker to get the specific device ID's current position. Now, we can also, if we wanted to, we can show the current position, but we can also show its history. So we can actually do the same request to show, for that device, get me the current position. Let's display that in, say, a blue marker. And then for where it's been in the last hour, let's do a query on that same device for history. And then let's just say in the last hour, trim it down to that many instances. And then let's plot each of those pins in, say, gray to see where it's been, or even draw a line to show, okay, this is where the device has been. So that
would be useful in one of those like walking apps to track where you've walked to or where you've hiked to or something.
Yep. So you can show not only where you currently are in real time, but where have you been? And then it's timestamped. So if you want to go back and look at it later, like you want to record all your data, like you were saying, let's say we've got a wearable device and we're tracking where we've walked, but then we want to simulate where we walked and how long it took us. You can actually look at all of the timestamps on all of that data and say, all right, well, we went from here to here and it took us 10 minutes, and we went from here to here and it took us 5 minutes. And then you can plot the distance that you've gone and the time it took, and yeah, basically exactly the same as your wearable fitness device. So the only other part to this diagram here is actually where I share the device data in terms of linking the device ID with the device name and the tracker, so that when we register a device for this end-to-end solution, we know what the device ID is to search in location service. So the only coupling bit between the two here is a DynamoDB table, which stores the device ID with the tracker that we're sending to, and then we can query on the tracker that we're sending to get all device IDs, so that we can then query the location service to get the position out. But so what I want to step through is actually just the mobile device. So this side here by itself. So actually looking at what does it take to get a cross-platform, so iOS and Android, but from a React Native point of view, to get location tracking up and running without using, like I was saying before, the MQTT protocol, using the IoT core, just a very simple application development way of doing it. So if you don't mind, I will jump into my code. And unfortunately...
Any questions on the architecture, by the way? Just let us know in the chat. And I'll let you continue on, Aaron. Sometimes it takes a little while to type. Yeah.
I'll pre-warn you, I don't think I'm as fast at coding as Matt and Paul are on cam. So what I've done is I've written the code out already. I have chucked it up into a repo so that you can grab it and have a look at it yourself. But I'm just going to step through the code instead of try and code it out, because I guarantee you I will fumble and fail if I try and code it at the same time as talking to it. So before I get into actually the AWS side of it and the location services side of it, what I've done for app developers, you may be familiar with Expo. So the Expo framework for using React Native for developing for cross-platform. All I've done for this project is set up an Expo init. So I've created a base mobile app. And then very quickly, the only additions to that base framework that I've done is I've actually added a tab navigator. So by default, it has a standard screen. I've removed the default screen from app.js, and I've actually added my own navigator in. And all that is doing is allowing me to tab between my main screen and my setup screen, and that will become apparent why in a minute. And I'll just quickly show you the screens. There's nothing to them. It's basically just saying this is the base setup for, I've got a simple header so that I can have the title, and then I'm basically displaying the main screen, which I'm pulling from screens, which would have been your main screen from the default app setup. So that's essentially...
So the other tooling that people might need is just the emulators locally?
Yeah, so I am running on an Android emulator at the moment. I actually have one running in the side. So I'll just pull it over. I've got my Android emulator. What you will need to run an Android emulator if you're running on Windows, apologies for those Mac developers out there. Yes, I'm running on Windows. Is you will need Android Studio so that you can set up the emulator device and then run your emulated device. But then Expo will be able to connect to the emulated device and simulate the application on the device.
Yeah, you actually have to open Android's virtual device once and load up an emulator and make sure it's switched on, and then Expo and React Native will be able to pick up. So I know a lot of the times when we do labs, that's probably like a main call out when people are actually doing the stretch. But once you've done it the first time, it should just be able to launch whenever you call the mobile device in VS Code.
I think the important thing to note there, Matt, is it should be able to launch.
Yeah, should theoretically. Sometimes you'll see actually in the bottom right-hand corner of Visual Studio Code, in the blue bar, the light blue bar, you'll see like a list of your devices that are active. Sometimes you need to actually change your device there. Other times you actually have to go like launch device in terminal or through the command palette. So sometimes, yeah, there's always caveats with mobile development, but that's something to be aware of. So as long as you've got the emulator launch, you're usually pretty good. Yeah.
I will be using the command line, so you'll be able to see it in action. But yeah, I have no end of trouble when trying to emulate onto Android. I apologize in advance if we have any problems.
I did get mine working in iOS Simulator. So I grabbed the code about half an hour ago and I span it up just to have a quick nose.
Awesome. Well, we probably have to jump over to your screen to maybe see it in action if my my local one's not working, as it wasn't working this morning when it was working yesterday. Anyway,
well, there was the Android update overnight, right? Like Android Studio had a bit of a major update, and then I think Haxum for Intel for running the emulator updated as well. And on the iOS end, the latest version of Xcode arrived as well. So you got to love these things. Like things work the day before, and then everything new drops for Android and iOS, and then you've got to retest.
The presentation gods don't like me, I think, because I was running all this yesterday and it worked fine. But then when I jumped in to get it up and running this morning, my emulator was the one thing that wouldn't work. So the one other thing that we're going to be using today is Amplify. So for any who aren't familiar with Amplify, Amplify is a application and web development framework. So it comes with SDKs to be able to work with the AWS resources in the back end, but it also comes with the toolchain. So you can actually set up and manage your resources in the back end. I'm not going to go through actually setting up all of the back end resources and everything now, but I will step through the actual resources that I've already created, just because I don't think I have the time to actually run through that. And it can take a little bit of time to create your resource and then push it up and wait for the actual command line to chug through and update all of the CloudFormation templates. But what I will point out is, so this Amplify folder here is the one that gets created when you do your Amplify init. So Amplify also comes with the CLI, and you initialize your application. So for those who are familiar with React Native and Expo but not familiar with Amplify, that's what this folder is. This folder is actually all of the assets that I need for the application for the backend and to integrate with the backend, with the exception of one, but I'm going to leave what that is later when I get into it. So before I get into the actual AWS side of it, I will pull up and show you how simple it is to go from setting up your standard React Native form and then integrating with actually the Amplify backend. So as I said before, I've got a main screen and a setup screen. The reason I'm doing this is because, as if you recall from the end-to-end solution, I want to register a device with the solution before I can actually start sending the data up. So what I'm doing on this screen here is I'm actually creating a simple form for the tracker name of the tracker that we've just created, the device, which is the device name, so a human readable name. And basically, all I've done is I've created a very simple form to collect that data. So when we run it, you'll just see on the setup page, it's a label, it's an input field, a label, an input field, and a button. And all the button does is the update handler is just doing a quick check to see if it's a valid input. And if it is a valid input, at this stage, before we connect Amplify, it's just dismissing the keyboard. It's not actually doing anything with it. But when we connect it to Amplify, and I will jump over to show the Amplify side of it now so that this starts to make sense. When we connect it to Amplify, I'm doing what we call a repository pattern. So I'm creating one class in the actual application that acts as a repository for all of the connections to Amplify, instead of integrating Amplify across the application, so that if I needed to swap something out, I'm not going to have to go through the entire application and find every instance of it. I just need to find the one instance of device, and device will be my repository class. So I'll uncomment that now, just the device class, and let's jump over to the device class. So when I work with a React Native app and building out a mobile device, what I generally do is I create a source folder. It doesn't have to be called source, it can be called whatever you want, but this is generally where all of my repository classes go. So what I've done is I've created the device repository class, and then by default, it's just a standard JavaScript class. What I've done is I've done my Amplify init, so I've actually set up an Amplify project. I've gone through and I've done Amplify add API. So Amplify add API will allow me to add either a RESTful API or a GraphQL API using AppSync. What I've selected is GraphQL, and I'll show you why. Because when we create a GraphQL API, let's jump over to our backend resources. I've created the API for GraphQL. We can create a schema. So when we create this schema, this is both the request and response object, and also is backed by the DynamoDB table. So I don't actually have to go and create DynamoDB separately and do everything. When I set up, create or add API and select GraphQL, all of the link between AppSync and DynamoDB is done for me through the use of this model.
So that's all through the Amplify CLI, right? Like you basically have that schema file, you run the add API, Amplify add API through the CLI, and then it's going to generate this file, which you can edit, and then it's going to send updates across to AppSync. It's going to send updates across to Dynamo. So you really don't have to worry about like having to replicate your schema structure everywhere. It's going to kind of do that for you, right? Yeah,
absolutely. It's actually even easier than that. When you go add API, it'll say, do you want to start with a base model? I said, yes, I want to start with a simple one, a no relationship model. And it gives you a to-do model, which is very simple: type, to-do, model, ID, and name. So all I've done is I've opened up the file that Amplify has generated, renamed it to device, and added a couple of extra fields. That's it.
And all of the infrastructure that Amplify is creating is referenced there in CloudFormation. So if you need to make changes to that, you can as well on top.
Yeah, absolutely. Big pardon. So yeah, absolutely. So when I run the Amplify push command, it takes the model, it takes the CloudFormation template that you just mentioned, and it actually pushes that up into AWS, and it runs the CloudFormation template to deploy the resources required for the GraphQL API, which will be AppSync. It'll set up the connections between the data source, which is your DynamoDB table that it also creates, and it creates the resolvers between the data and the model that you've created. So the data and the AppSync through to the query. So now you have queries and mutations, which is queries, get and list, and mutations, create and update. All of that's created for you in the back end, but also as an extra step, when you're going through and deploying that, and this is another reason why we have our source folder, it'll say, do you want to generate all of the queries and mutations as integrated code? So we say, yes. I haven't had to write any of this code here, and I have all of the mutations, which is the create a device, update a device, delete a device, and queries, which is our get device and list devices, all that's generated for me in the format, in the GraphQL format that I need to make a query to a GraphQL endpoint. So now,
and by the way, you can generate location assets with CDK as well, right? So I think you've created some stuff in the console today. We've got Amplify for web front ends, but if you want to build things through CDK, I did see someone call that out in the chat, and I think Paul's pasted the link to that as well. So just to call out that you can build these assets in CDK. And one other thing that I did want to call out, just monitoring the chat, was where is it again? Actually, yeah, I'm interested in seeing who's built something with React Native so far. I'm hoping this looks familiar to at least some. So give us a shout out on the chat if you have built an app with React Native so far. I'll let you continue, Aaron.
Just as an aside, I have actually written a blog post. It is up on the AWS blog on integrating Amplify with existing resources. So to that statement before around using CDK, absolutely go and create your app sync through CDK or even AWS API Gateway. Go and create those resources through CDK, and for your outputs, just take the endpoints, and then you can actually configure them into the application. And that's probably a good segue into what I was about to say around the rest of what's in this source folder. So the mutations and queries, that's specific to GraphQL, but we still need to link the endpoints for Amplify and anything that's created in the backend. What's also generated by Amplify is the actual the configuration for those endpoints. So when I've gone and created that model and then pushed it up, it's created the endpoint for me, and it's actually linked it into the AWS exports file. Now, you won't find this AWS exports file in the repository because, again, we're very security conscious and we don't want to be handing around all of our public endpoints to people. So you will need to go and create your own Amplify app and then create your resources and add your own AWS exports, but the rest should work straightforward. And then also, the one other thing that I did as I was creating this API is also add some very basic API key authentication. So it's not using any complex authentication. It's just getting a temporary token to then send the data to the API or to AppSync. So that auto-generated file, all we need to do when we actually set up our Amplify repository is the first one is import Amplify. So we're importing Amplify library, the AWS Amplify, and we want to import the actual config. So importing that AWS export config file and link the two together. So under the Amplify class, we select or we call configure and add that config file. And that has now linked the AWS exports file with all of the Amplify configuration so that we have everything set up now to query AppSync, to do any querying to any resources we set up. The last bit before we actually get into the code of what we're doing is we then just need to import the actual the GraphQL queries that we want from our mutations and queries that we want to query in API and the actual specific library. So we're going to call the API library, which is another AWS Amplify library, and the GraphQL operation. So we know that it's a mutation or it's a query. So using those libraries, let's quickly jump into the actual repository code. And one other thing, what I have done is I'm also using the local file system. So when I create or register a device, I'm not actually creating an ID for that device. What I'm doing is I'm relying on the model to provide an ID for me. So when you actually specify an ID here, that's saying that it's an AWS ID or AWS generated ID, and the exclamation here in the GraphQL notation means that it's required. So actually, when I go and create a entry, I can send in name and tracker only because they're both required. And when it creates the item in DynamoDB, it will generate a GUID or an ID for me. So I'm actually relying on that to send back to me. So when we go and create our where are we? Register a device is going to go and create. When we go and create our device, we're calling the Amplify API library. We're using GraphQL, not REST, and we're using the GraphQL operation of create device all I'm handing in, this is my input for that create device object, is the name of the device and the tracker. What I expect from that response is it's going to give me the auto-generated ID. And then all I'm doing is I'm storing that auto-generated ID under the right function here, which is what I wrote above, into the local file system. So all I want to do is, once I've got an ID for this device, store that. I don't want to store the tracker. I don't want to store anything else because I want to be able to change that. And I may want to change that from another application, not specifically the application that I'm sending from. So in that way, when we actually initialize the app and run it, it'll do a quick check and it'll say, oh, this is the tracker I want to send to, and it'll start sending to the tracker. The rest of the code, this is register is very simple logic, looking at the difference between create and update. So are we creating a device or are we updating the device? That's really just looking at, do I already have an ID or don't I have an ID? So if I already have an ID stored locally, then I'm making an update. If I don't already have an ID, then create a new device. That's as simple as all it is. So we're just running the API from Amplify, GraphQL operation of update device. And then this time we need to put in the ID so that we know that we're updating a record, and then we can update the name and tracker as well. So that would be from the setup screen, register a device or update the information in terms of the device name or the tracker that we want to send to. And then all my init function is doing is it's just initializing whether the actual file exists. So do we have an ID? No, we don't. Then get device. Sorry, yes, we do. Then get device from GraphQL. So we have an ID. Let's get the device information and store it locally in the app. That's as simple as this repository class is, and that's all we need to do in terms of linking Amplify with with Amplify to the back end. The next bit that we need to do is following the same pattern as I was saying before, using IoT core, sort of MQTT through IoT core into location service. We're following that same pattern, but this way we're using AppSync as our way in. So we're now sending data to AppSync, and what we want to do is we want to create a lambda to talk from AppSync over to location service. So the next thing that I've done in Amplify is I've gone and created a function. So it's as simple as Amplify add function, and that does exactly the same thing. It generates the backend configuration, and by default, it just gives you a very simple index.js and the request handler, and that's it. So let's quickly jump into what I've done. And all I've had to do to link the Lambda to location service is pull in the actual AWS SDK. So we do have the API, the location API in the AWS SDK, the JavaScript SDK, this one is. So we can access the location endpoints or APIs. And all we're doing is we're initializing location from the AWS SDK. And then from there, all I've done is I'm creating an object of all the parameters that I need to send to the location tracker API, which is just our tracker name. So we need to know, the API needs to know what tracker are you sending to, and then update. So as I said, it's using a bulk update function. So we can actually send an array of all of the items that we want to send in. For this one, I'm just sending an individual device location update. So we're handing in one device of the device ID, the position, which is latitude and longitude, and that's all going to be sent to us through the actual app sync to the Lambda. And then the sample time is basically just getting now. And then that's it. The rest of the handler is actually calling the location batch update device position and sending that object to the API, and that's job done. So that's the logic that we need to send from AppSync through Lambda into location update. Now, the one other important thing that we need to do, if you're working in Amplify, you do this through the CloudFormation template, but if you're doing this through CDK, obviously you can do the same configuration through CDK, or you can do it in the console. You actually need to set the permissions for Lambda to talk to location service. Because remember, everything we do in AWS is least privilege. So we actually now need to say, hey, Lambda, you can talk to location service. And that is as simple as in the location service CloudFormation template, we're adding into the execution policy an allow of geo batch update device position. So this is now allowing this lambda to talk to the batch update device position API. And then we're specifying we want to use the current account that it's sitting in, and basically allowing anything under tracker to send, anything under this account in tracker to send to. And that's it. So that's given permission for this lambda to talk to location service batch update position. Now, the only thing that I would do there is do my Amplify publish again, Amplify push again, and that would update the backend to add the function. Except now we want to add, so we've got a function, we've got AppSync. Now we actually want to call AppSync to do that. The one last thing we do, you might have noticed when we were on the model screen, is add an additional mutation which actually calls that function. So instead of having to create extra code to go and update or call a lambda function separately, we can do it through the lambda through the AppSync. When we add the mutation and we're calling it update location, we specify what's the data that we want to send to this mutation. So we're sending the tracker name, we're sending the device ID and the latitude and longitude, and we want to link it to a function. So we're actually using the @ function and the name of the function. For reference, when I create the lambda, I create it based on environment. So I can have multiple environments all with specifically named for that environment. I do the same thing here and say, get the environment variable for the current environment, so that when I'm executing this in any environment, it'll actually look at, well, update location for prod or update location for dev. In this case, it's dev. That's it. So now if we do...
So what that is that's just you've just codified the lambda resolvers for AppSync.
Yes, absolutely. So that if I do push, again now, Amplify push, what that's doing is it's creating a data source as a lambda function under AppSync, and it's linking the AppSync mutation to that lambda data source in AppSync, but providing, and then also providing the generated front end code. So if we go back into our GraphQL mutations, it's also creating this update location mutation. So this is the generated GraphQL query that we need to call to send to AppSync, which will then send to Lambda, which will then send to location service. And then to call that, it's as simple as what we were doing before. So let's go back into our device. And the very last one here, we have set up our wrapper for that, which is the set location function. All we need to do is send latitude and longitude. Our tracker name is stored, because we've done the init, is stored locally inside the tracker class. The device ID is stored locally inside the device class. All we're sending is latitude and longitude to this function. And then we're calling API GraphQL again with the update location mutation and the information that it needs for that query. Simple as that. Now linking that very quickly, we saw before we created the device, or we imported the device into setup. Obviously for ease, I'm just initializing that class in this screen. What I would usually do, which is a little bit more complex, is I would actually initialize it at a much more root level, so at the index level, and hand it up, so through dependency injection through the navigator, so that when you get to that screen, it's already been initialized, it's already there, you don't actually need to initialize it. But just to show you, it's as simple as initializing it, and now we're using it. So I can now set device register, and that's going to call the register function in our device repository class, and done. We can now run that, create a tracker name, create a device name, hit register, and it's going to send it through to AppSync and DynamoDB and store it. The last bit is a little bit more complex, but again, it's simple. If you're used to React Native and used to Expo, we're importing the Expo location library. So this is the library for your React Native that will allow talking to the local GPS service on your device. And what I've done, so before we're actually showing the hookup to the device service, is First of all, obviously, you need to request permission. So the first time they run it, it will prompt, do you allow permission for this app to access your GPS? It won't work unless you allow or request permission and allow. If it's allowed, it's then going to do a quick check, is location service enabled? So does my emulator actually have GPS? It'll tell me yes, it does, or no, it doesn't. Or does your device have GPS if you're running on a physical device? And then I am just pulling out as an extra the location provider status, and I'm logging it to the console so I can see, is GPS enabled? Is location service permissions allowed? And all that. So that's just an extra debugging feature that I usually leave so that I can see it running in the console. So if the service is enabled, we're doing a query to get the current position. So that's going to talk to the local device API to get the current position. I'm using high accuracy, so it's going to be within meters, not a larger radius. And then if I'm actually getting a location object back with coordinates, I'm logging it to the console so I can see it, and I'm setting the state location object for React. So this is the React part of it. I'm just setting the location object into state so I can use it for, say, displaying it on a map, or what I'm doing down the bottom here is displaying it on the screen in text. So I'm showing the current latitude and longitudinal position on the screen. The last
Aaron,
bit to that,
when we posted our little teaser, you looked a little bit stressed, and we were wondering whether it would compile. And I'm just noticing that we've got about 4 minutes to go.
Yep.
So let's see if this compiles.
This is okay. Let me undo the last bit. I'll just quickly say the last bit that I've added here. Let's uncomment the bits where we've hooked it up to our device service, calling the set location function. That's all this is doing. The last bit that I've done here is set a watcher. So I've set a watcher at high accuracy within a distance of 1 meter. So if I go outside of 1 meter from my previous position, it'll then send an update to this function. All that function is doing is, again, updating the local state location and sending it to the set location. Simple as that. That's all I've done in terms of sending the GPS coordinates to location service. And let's just I've done an initialize so that we can get our tracker name, our device name, and our device ID when we first start this up, and make sure that we actually have. So let's jump into the console and make sure that everything is saved. Let's try and run this and see if the presentation gods are going to be nice to me this time and allow it to run on my emulator. So let's pull that across here.
Matt and I were just chatting last week that connecting all those wires up, when I set up all the LEDs on the breadboard, I was pretty pleased that it actually worked at the end.
Yeah,
you do when you do something live or you do something the first time, it's like one little wire, one little comment somewhere is not right, or a little bit of cache in the emulator or something could cause something to happen there. So yeah, hopefully this works.
Okay, I'm going to. Okay, it's not responding. Still waiting. All right. Well, while that's waiting, I'm gonna quickly jump over and show you. I don't have it here, right? Awesome. Didn't prepare. You can see. Oh, that's why I've run it on the wrong screen. All right, the screen that I was using there was actually the pre-designed query that I had to actually query the API tracker. So I can. Where are we? That's still. Let's see if I can. Okay, it's going to open in Android. While that's running there, I'll jump over to this other PowerShell and I'll type it out. So using the AWS command line console, I want to call the location service, and I want to do the list device positions for the tracker name. Now, I'm not going to use the tracker that we just set up because I haven't sent anything to it, but I do have. In the console, I had mobile lock is the one I was using yesterday. So tracker name, mobile lock. see if my connection is going to allow me to try and emulate. Okay, so you can see here is an entry in the tracker mobile lock coming from the location service. So we've called the AWS command line location service list device positions, and this is the current position for, this is the auto-generated device ID. And there we go. So the Matt, do you want to jump over and demonstrate the app on your screen? Because you did have it running before, and my emulator is not being friendly. I think you're on mute, Matt.
Yeah, just setting my screen up to be shared. Paul, do you want to add me in now?
Yep, there we go.
Cool, excellent. So yeah, I basically just took the project that you gave on GitHub, and you might have seen me distracted in the background, but I span it up. I'm still generating the Amplify environment, but I've got the device tracker lat and long, so those are 2 coordinates that you might have had set up, and then I can see your setup page here as well. So maybe do you want to talk us through what's happening on these screens?
Yeah, so on this setup screen here, all you need to do is under tracker name is give it a human, friendly name or readable friendly name. Yeah, and then under tracker name, that would be where you would put in the new tracker that we created. So new tracker in camel case. Yep. And click register. And that, as long as you've got the Amplify side all set up, will
not quite yet. So that's okay. Yep. Cool.
So that would then register it in DynamoDB. So you've now got a device ID generated from AppSync, which will send back. It'll then store the device ID on the device locally, and you've got it linked to the tracker and a friendly device name. And then if you go to the main screen, what you would see here is if the Amplify side was set up, it would show you the device friendly name and the tracker. Again, remember, I'm not storing the device name and tracker name locally. I want to store it up in DynamoDB so that we can make changes to it from the other end, the web app side. But we are showing the latitude and longitude because that's coming from the local device. And then essentially, the first time you load this page, it's going to send it up. Or if you step outside of a meter of where you currently are, it'll then try and send it up as well. So all it's doing from this screen is sending your location. Now, the next simple step would be adding a map. And you can, instead of showing the latitude and longitudinal position, you just put a pin on the map where exactly you are. And that's all front end. It doesn't require any AWS location service side unless you're using the map tiles. Then you'd be querying for the map tiles. But one thing to note on that is for using map tiles and other things not that we've covered today, you do actually need to be authenticated. So to use a lot of the map tiles and stuff, you do need some form of authentication. So the actual simple token that I've used to talk to the API won't work. You will need, say, set up Cognito, log in, and then talk to the map tile service to get your maps.
No, that sounds awesome. I do know that we're on time. Yeah, I know you were just about to say, Paul, as well. I think this has been really useful.
Well, I was just about to say that I think, we might have to pick it back up and then wrap Cognito around it, take the existing app, wrap Cognito around it, and then pull down some tiles in a part 2.
Yeah, I'd love to see some tiles. So let's schedule you in a couple of weeks, maybe, Aaron, and let's get it all happening visually.
We could, in as a suggestion, we could do the other side of it and show the web app using the map tiles and show the actual mobile device on the map so that it's not the same. You're not showing the map of the on the device and the current position. You can see it working end to end.
Yep. Yeah. No, that'd be cool. Or even have Raspberry Pis generate locations that we can track, or we'll think of something cool. I know we are spot on. So I guess a quick summary, as I know we've had some people in the chat kind of ask. Amazon Location is a really good service that you can effectively map out tiles. You can set different locations around the world. So you can kind of like, maybe I'll get you to explain it a little bit better, Aaron. I'm still needing a coffee right now.
No worries. So summary, location service allows you to generate or receive map tiles so that you can actually display a map as most people are used to in their applications. But it also allows you to create your Geofence location collections. It allows you to do point of interest lookup, and it allows you to track devices. So you can send individual or batch updates of devices and then tie them together. So then you can tie your tracked devices with your geofence locations, display them on the map, and it allows you to then build out a much bigger back-end ecosystem to send events or whatever it is. If you're doing notifications based on geofences, all of that is central to location service working in with other AWS services.
No, that's very nice. Excellent. Well, we're going to have you back, Aaron. We've probably got somebody queued up that wants to use Twitch after us. So let's wrap it up today. It's been a pleasure having you as our first guest appearance on the show, and I hope the audience really enjoyed the session on location. We will do something in the future. Paul and myself will see you next Wednesday. I think we're going to have a look at App Runner, but don't quote me on that. But next Wednesday, same time, 12 p.m. AEST. We're always broadcasting during Australian lunch hours on Wednesdays. So we'll see everyone then. Thanks for that, and thanks for watching. And it was great learning about location today. Thanks, everyone.
Thanks a lot, Aaron. Thanks, everyone. Take care.
Everyone. Bye.
See you next week.